Today I'm going to talk about large-scale assessment of protein function prediction using heterogeneous ensembles. For protein function predictions, different people might use different softwares models like PFP, ESG, Evoco, Prisco. Heterogeneous ensembles allows the inclusion of diverse models without the restrictions of their types or number. But the question is whether or not heterogeneous ensembles can improve their performance compared to just using one single predictor alone. To answer this question, we previously built a software based on nested cross-validation structure to train the base predictors and the ensembles independently to reduce the overfitting. So as you can see from the right corner table, the aggregated stacking performed better than best base classifiers for all three cases. But due to computational costs, we only tested on 3 Go terms. So excuse me. In this project, we used a high-performance computing strategy to test heterogeneous ensembles for 277 Go terms. So first, we extracted the streamers from the protein sequences and normalized by the length of the sequences our feature set. We then resampled the training data to 10 bags to address the imbalance and introduce diversity among base classifiers. And then we trained base classifiers for the 10 bags. We aggregate the predictions from 10 bags for each base classifier. In the last step, we trained the ensembles based on on top of those base classifiers. So we used 3 kinds of heterogeneous ensembles. The first one is an unsupervised version, which takes the average of all the base predictions. And the second one is stacking, which builds a meta classifier on top of those 12 base classifiers. And the last one is CES, which is an ensemble selection method. So it iteratively adds one base classifier to the model that optimize the overall performance. So all of these are done in a 5-fold nested cross-validation. We use 12 base classifiers. We tested on 8 stacking methods, CES, and a mean ensemble. So let's talk about the results. So this is a box plot of the heterogeneous ensembles Fmax improvement compared to the best base classifiers. So the y-axis are the heterogeneous ensembles we used, and the x-axis are the delta Fmax compared to best base classifier. And we also categorized the Go terms based on the number of annotated sequences. So you can see here we have 3 subgroups. So generally speaking, most heterogeneous ensembles perform better than best base classifiers. You can see most of them are greater than 0. And with more annotated sequences available, our heterogeneous ensembles performed better. So we also want to know if there's any statistically significance for the rankings of these methods, these ensemble methods, and the best base classifier. So we did this critical difference plot based on Friedman and Namae's test. As you can see, stacking used logistic regression performed significantly better than any other methods. And finally, we want to know if our heterogeneous ensembles perform differently at a different level of the Go hierarchy. So we define the level of a Go term as the length of the shortest path from the root node to the current node. You can see from the box plot, the bottom one, actually the stacking using logistic regression, the improvement of this method compared to best base classifiers increases for deeper Go terms, which is very interesting. So yeah, actually I did leave one species out cross-validation, but I don't have time to talk about it. You can come to my poster session later. So I would like to thank the National Science Foundation and Function COSI for their travel fellowship, members of PandaLab, FungiCAD, iGetCAD team members, the high-performance computing team at Mount Sinai, and the funding resources. So for more details, please come to the exhibit level at 6 p.m. to 7:30 p.m. today. I would like to discuss with you guys. Thanks.
At most one short question while the next speaker is preparing. How many different Go terms?
So here we tested for like 277 Go terms. So as long, I think, what do you mean by, so that's it?
Yeah, that is
Okay.
all right. Thank you very much.
Thanks.
You.